CORVUS is a multifunction test tool designed for aircraft maintainers and system integrators. This video covers why and how it's used. Hidden within the racks and interior of every operational aircraft is a complex network of cable assemblies connecting sensors with flight processors via a digital bus interface. Often, these cables are difficult to inspect either visually or with a common continuity tester, and they are invariably a source of problems, especially in aging, high-use aircraft. Dragoon ITCN, with Air Force Research Lab support, has developed and fielded a new Swiss Army knife test tool that greatly reduces the time required for troubleshooting and validation of aircraft avionics systems. CORVUS will enable multiple test functions in a lightweight portable enclosure. CORVUS will provide maintenance personnel with the ability to validate the cable assembly and capture the digital bus interface information when it's active. Let's look at the specifics. Now let's look at how CORVUS is used. Starting with the splash screen upon power on, each of the functions are represented with an icon. We will cover Vector Network Analyzer, or VNA, Digital Video Interface, or DVI, Time Domain Reflectometry, or TDR, followed by MIL Standard 1553 and A-Rink 429 bus interface monitoring. Click on the VNA. We change from the S11 measurement, which is return loss, to S21 measurement, which is the insertion loss. Then we need to go to scale and auto scale. This cable is being used at a relatively high frequency, so it is pretty lossy, but we can correct for it using the normalization feature in the VNA. To use the normalization feature, we would go to Display, Memory, and then Normalize. Now the cable is zeroed out. Click on the icon for DVI. In this test of the DVI function, we have pair 2 selected. We can see an impedance mismatch at 5 feet, where the end of the 5-foot adapter cable is connected to the 10-foot commercial DVI cable. We can see the end of the 10-foot DVI cable at the 15-foot mark. There is an impedance mismatch where we have connected another 10-foot commercial DVI cable, and at 25 feet we see the end of that 10-foot commercial DVI cable, and it's open there, so you get quite a bit bigger mismatch. We can select the 4 pairs, select pair 3, which is very similar to the first mismatches. We can select pair 4, and we'll see very similar responses with pair 4. Now we're going to select pair 1. When we select pair 1, there's an additional mismatch, which is in the middle of the first 10-foot commercial cable segment. So at the 5-foot mark, or 10-foot in this case because of the 5-foot adapter cable, we can see there is a problem. In this particular cable, pair 1 was damaged. There was some untwisting of that particular pair and it caused a mismatch. This is what we are looking for in this test, is a mismatch in the middle of the cable where we shouldn't have one, or a bad connection with a high mismatch. Now that concludes the DVI test.
On this icon right here. For this test, we're going to do a triax test. So we're going to switch to outer triax to get started. And we are going to set our lead to 0 because we're going to figure that out right now. Our lead to 0. And we got to set the VOP for this cable, which this cable has a VOP of 68. And we're going to run. And right here you can see that this cable is about 30 feet. So we're going to actually we're going to go ahead and set this to 30 feet. Done. And now our lead cable has been effectively zeroed out. I'm going to go ahead and hook up a cable under test that is 60 feet. And as you can see right here at about 60 feet, it goes open, which is exactly what I expected. Now this is a triax, so there's two connectors. We'll go ahead and get the inner trace. As you can see, we have the inner and the outer trace going at the same time. And now I'm going to induce a fault at the end of the cable. I'm going to induce a short on the inner connection. And there is a short to ground at the end of the cable, which is what I expected. And we can do the same thing for the outer. And as you can see, it refreshes in real time. When I remove the error, everything goes back to normal. On bus monitor. And then we have this screen, which for now we're going to just view the default configuration. And it'll bring up our default bus monitor page where we have channels 1 through 4, and we have RT 0 through 30. And you can actually scroll all the way to RT 31. And now I'm going to simulate some bus traffic. We actually already have our cable hooked up, and all we have to do is hit play. And we have a generator of 1553 data. As you can see, we have green for good data, red for errors, and we got a Christmas tree configuration. Let's click on one with errors. As you can see, we're constantly getting errors. We have status word errors, no response errors, and we catch every single error that comes in and we log this away. So when we're done, we can actually save this data, and it exports it onto the SD card on top of the unit so that you can pull it out and record the data later. Now, if you want to set up a custom bus, you will have to have a database already set up. But once you have the database set up, you can bring it up here, open it, and as you see, ABC 123 bus A. We're going to click on bus A, and we're going to edit it. As you can see, we have a blank screen right here. What you want to do is you want to add a connection, and there we go. We have our first RT. Now we can go in here, we can rename the RT to whatever we want. We can say it's actually A or ABC. And then we can add another connection and name this one this one 1, 2, 3. And you can add as many connections as you like. You can even change the order and change which RTs are where. And you can get really complicated with it if you'd like. You can make this one all the way over here if you want. And then you can save this. And then once you've saved it, you can just view it. There's our beautiful bus monitor database that we created on channel 1. We're going to hit play and see if we can collect any data on it. And right there, you see, we can still collect data on the generated ports that we have made. And we can still go in here and see all of the error messages that pop up on a given channel. And on ones that are green, we can see that there are none. And that's how you use it. To do that, we have to select the wire mapping icon. And I have already connected a test cable to the port on top of the unit. And what we're going to do is we're going to read that cable and see what connections go where. As you can see, we have 32 connections and we have one-to-one connections. So 1A goes to 1B, 2B goes to 2A, and so on, all the way down to 32. Now, what we can do is we can save this trace, and now what we can do is we can compare this to what we just saved. So we're going to go ahead and open that file. And when you do that, it's going to tell you whether your connections are actually good on the current cable that you just read. Now, what I'm going to do is I'm going to introduce a fault into this cable set. So we're going to disconnect a few of the connections. We're going to select read again. And as you can see now, we're missing a bunch of these connections because this connection is loose on top of the unit. And if we compare with our known good cable, it'll give us a bunch of error messages. So 1 through 8 is not connected, 20 through 26 is not connected. So you would know when you're troubleshooting this cable that you have a few loose connections because you saved this configuration, you brought it up, and it's changed. Now I'm going to show you how to use the configuration editor. This is how you actually set up a database for all of the other applications on CORVUS. You have to go to configuration editor. And as you can see, you have a few options here. You have aircraft type, tail number, bus, and cable. You can also add segments or whatever, but for now I'm just going to set up a basic database. First thing you have to do is an aircraft type. We're just going to call it aircraft A, B, C. And we'll hit save on that. So aircraft A, B, C. For tail number, we're going to say this is tail number 1, 2, 3. Done. And save that. As you can see, ABC, tail number of that. Now we have to add a bus. We're going to add bus A, and you have to say the cable type. We're going to say 1553. You could also do 50 ohm or Ethernet, depending on what you want to set your database to. Save. And then if you knew a cable, like a test lead, you could save it here, but I'm just going to save this as is. Save. And we are going to save this as a demo. We're going to call it demo test. And we're going to save that there. And then we close the application. And now when we bring up any of our other applications, we'll be able to save any of our traces to that database.
Using the Corvus is unlike any full function tester in that it can be operated in confined spaces by a single operator. As shown, Corvus is making aircraft maintenance easier, but combining essential functions into one portable tester. Our engineers are available to visit your facility and prove it.